Hai, Assalamualaikum warahmatullahi wabarakatuh. Honorable Ma'am Afia Hayati, as a lecturer in this course, I am DEFFA RAHADIYAN. I would like to explain about application of computational intelligence and machine learning. As we know, artificial intelligence or AI is a wide-ranging branch of computer science concerned with building smart machines capable of performing tasks that typically require human intelligence. To do some tasks such as classification, regression, and then machine translation or detection, AI needs an learning algorithm. Learning algorithm is an algorithm that is able to learn from data. Actually, machine learning has some type of algorithms such as supervised learning and then unsupervised learning or reinforcement learning. One of the simple machine learning is linear classifier or single layer perceptron, where it needs one classifier to classify the data that has two classes. How about if the number of classes or the number of data is increased or complex? We can use multi-layer perceptron. The differences between multi-layer perceptron and single-layer perceptron is if in single-layer perceptron it has only one output, output and input, but in multi-layer perceptron it has input, output, and hidden layer in the middle of input and output. How about the number of hidden layer? How to determine the number of hidden layer? If the data can be visualized, we can visualize it first, then we can determine the number of hidden layer. But not all of the data can be visualized. So we can use computational experiment. How if we have a big data? To process a big data, we need so many hidden layers. So many hidden layers make the number of classifiers increases and the complexity is increases too. So multi-layer and simple multi-layer perceptron cannot be used, but we can use deep learning. Deep learning has some many types such as encoder, CNN, GAN, and ATC, but in this case we will use CNN. This is a CNN architecture, but in this case, but I will explain an common architecture of CNN. The first one, there is input data in here. Input data is easily a matrix from an image. So the input is image, then a pixel from the image will be convoluted in here. This is convolution layer, and then feature map, and then convolution again, and feature map again. The number of convolution and feature maps is based on our system. So each system has each characteristic. And then the last is output. Before output, there is a fully cognited. This is a multi-layer perceptron. Nah, in here I would like to explain example case The title is Identification of Plant Nutrient Deficiencies Using Convolutional Neural Network. As we know, a plant is a living thing that grows in earth and has a stem, leaves, roots, and maybe have flowers or fruits. And hydroponic is a farming system that using water as a growing media. In hydroponic, nutrient will mix with water and flow through roots of plant. The number of nutrient or nutrient content in plant is has a big effect for the plant. If the nutrient is not enough as a plant needed, the plant cannot grow well. So we have to know the best the nutrient content in plant, so we can give a certain nutrient for plant too. Some method has been done to know the content of plant as a non-destructive method and destructive method. Destructive method is just for an expert. It cannot do by common people. That's why a non-destructive method will be need. Nah, non-destructive method can use image processing because as we know, image has an information that can be analyzed, so we can get the pattern and we can know what's wrong with the plant. Some research has been done, but it just identification one nutrient on plant. In this case, we will identification more than one nutrient deficiencies in plant based on leaf image. The method that will be used in this case is CNN because CNN has been implemented on other research and give a good result. And then CNN is machine learning or deep learning that can process a big data. Based on the background above, so problem is the previous research could achieve an accurate performance, but they studied only on one or two types of nutrient deficiencies, making it less practical in real situation. Purpose is to design and build a nutritional deficiency identification system on plant leaf image using CNN method. And benefit is that nutrient deficiency in leaves can be identified in the real system. The dataset that will be used is playground plants grow under nutrient control, and then healthy black gram seedling with approximately the same height were chosen. Each had been moved to a bottle of nutrient-controlled solution and was to grow for 28 days. 6 different types of solution were used in the experiment. The first is complete nutrient, the second one is calcium deficient, the third one iron deficient, magnesium deficient, nitrogen deficient, and the last one is potassium deficient. Based on the image, based on this picture, we can see that This is the picture of complete nutrition. This is calcium deficiency. This is Fa deficiency and ATC, and the last one is K deficiency. From this picture, we can see that each deficiency has their own characteristic. Data acquisition. The image of background levels were taken every day, except day 20 due to a problem under a controlled-like condition. And then one or two images, older and younger leaves per plant. To take the picture, the SLR camera has been used. In total, the number of datasets is 3000 of leaf image with a resolution 1.26 29 pixels. Each image contained a target leaf which was manually segmented by human. This is a nutrient deficiency criteria. There is 4 types of deficiency: calcium, iron, magnesium, nitrogen, potassium, and this is the characteristic of each deficiency. And below table, the table below is about the number of leaf image in the dataset. For the complete nutrients, the number of plants is 10 and the number of image is 519. For calcium deficient, the number of plants is 11 and the number of images is 412. Iron, magnesium, nitrogen, potassium, and the total is the number of plants 63 and the number of images is 3000. To check the performance of the system, we use this one: precision, recall, and F-measure, where precision is similar to true positive divided to true positive plus false positive, and recall is true positive divided with true positive plus false negative, and F-measure is 2 cross precision cross recall divided to precision plus recall. This is an architecture of the CNN that used in the system. We can see that this is an input image. Each block will separate like this. In here we have 3, 6, 6, 3, 3, 3, 54 block, but we just take an block that has a color like this, and then each block will have each block level decision. For example, this one is block level decision. For example, this one a block level decision. For the first one, do convolutional polling and pooling for each CPLT, FA, MG, K, N, and ATC. And then check the result. The result is the value of each criteria such as FA, MG, CPLT, and ATC. From this block, we can see that for CPLT, the value is 0.33, for FA is 0.65, and for this is ATC, and the last one is for magnesium or Mg is 0.87. And then we will check each value and we will choose the highest value. From this one, the highest is Mg, magnesium. For the top is CpLt, and for the bottom is Fa. Each value will be checked for the proportion calculation. After that, we can see the highest two, and then from this one we can see that the highest is Mg with the proportion is 45%. So after this, we do multi-layer perceptron to choose the highest one, and the result is Mg. This is a example picture image of the block. This is a halt leaf, and in the bottom is the leaf that has some deficiency. After that, we can see the result. The result is the complete one has a precision 83.76 with recall 92.45 and F measure 87.89. This result will be checked to human result, and with overall, even the proposed method has a low accuracy, but the accuracy is higher than the human. Precision of human do just 27.37, but this method is 43.02. So, what's wrong with the result? So, based on the result, there are great variance of symptoms caused by deficiency of the same nutrient within class variation. It means, based on figure 4, demonstrate a progressive development of symptoms caused by magnesium deficiency. The appearance of symptoms became slightly noticeable on day 11 after stress and greatly developed since then. Necrosis region or brown regions on the left and right borders obviously appeared on day 13 and turned into white on this one, 19. Additionally, the other green regions of the leaves become yellowish on day 25. Second, the symptoms are not obvious in the early stage after nutrient control. Based upon our observation, it took around 6 until 10 days for the symptoms had become visually noticeable. Consequently, during this stage, it would be very difficult to distinguish a nutrient-deficient leaf from a healthy one. As an example, shown in figure 4a, this is figure 4a. This is a magnesium deficient on day 6 after stress. It seems like a healthy leaf, right? The third one is the symptoms of a nutrient deficiency at the stage might be similar to those of another deficiency. Okay, based on this figure, 4C became irregularly shaped, which is a key of symptom of calculation deficiency 1B. Okay, we can check 1B. This is 1B. It's similar actually. Also, this is for calcium deficiency. And this one is magnesium deficiency. It seems similar. The fourth one is the symptoms are hard to detect because they are small in size, especially when they start to develop. Furthermore, some other parts of the leaf where symptoms have not yet appeared would be indistinguishable from a healthy leaf. Okay, so the conclusion of this research is experimental results present the feasibility of using CNN to identify nutrient deficiencies in breadcrumb plants based on their leaves and indicated its superiority over human in performance comparison. Although the proposed method could not achieve a very accurate identification performance, it was notably more successful than the 10 humans overall. Suggestion. The first one is further analyze on the time factor, for example, death after nutrient deficiency stress and ATC. The second one is how soon the deficiencies could reasonably be identified in the early stage will be studied. The third, other factors including nutrient mobility and leaf age, for example younger or older leaves, which can affect the symptoms, would also be considered to improve the reliability of the identification. The fourth one is aiming at being more practical in real situations. Multi-nutrient deficiency lacking of two or more nutrients should be further investigated in the future. So, thank you. Wassalamualaikum warahmatullahi wabarakatuh.